Hi, this is Anthony Williams with NDE Solutions. Thank you guys for allowing me a little bit of time to talk about proper ERW weld inspection. Today I'm going to do a brief summary on how ERW welds are made. I'm going to do a little bit on ultrasound and phase array as well. And we're going to do a short talk on how the problems with pipelines are found, just so everybody understands what it is that we're talking about. Okay, folks, let's get right into the modern process for finding and inspecting integrity issues in a pipeline. First, we have internal inspection using pigs, which gather data and complete different functions on the pipeline. For those that don't know, pigs are NDT tools that navigate through the internal pipeline. They have multiple functions, and here are a few of them for you. We have cleaning pigs. Cleaning pigs, folks, we got to keep a clean pipeline to keep things flowing well. Then we have ultrasonic pigs. We also have MFL pigs. Both of those do pipeline integrity. We have caliper pigs, which give us the pipe geometry. They have XYZ pig, which gives us good location on where things are in the pipeline, and many more. We have external issues which are found visually by pipeline employees which go out daily to inspect the pipeline. They find things such as this corrosion that you see here. This can be a problem that can cause an early failure, so we try to repair that as quickly as we can. Sometimes problems can be found by the public as well. These problems are similar to this exposed pipeline here. In a flood situation, this could become a problem when things start hitting the pipeline, such as small trees. Here is a brief video on the ERW welding process. Now, if you notice, the pipe is actually rolled from flat steel. Here you'll see the electrodes being activated, whereas you have a heating of the pipeline, and in that you see the pipe being pressed together, and it will start creating a weld situation right here. This is high frequency ERW weld, which is normally the preferred method due to the fact that we have less problems such as hook cracks and things of that nature. Here is a good example of how the seam is actually shaved off in the ID of the pipe. Both the ID and the OD seam are shaved off of the pipe. Everything else is just a quenching process to harden the steel and make sure that we have a strong pipeline. I felt like you guys really needed to see this so you can understand the whole process of doing an ERW weld. I enjoyed it, I know. Okay, a little bit about the weld symmetry of a ERW weld. This is the actual shape of an ERW weld, and if you notice, the cap is still left on here at the ID and the OD. This is after it's been shaved off. If you notice the smooth surface, which makes it a little difficult finding the ERW weld sometimes, but we always accomplish it. We use ultrasonic and phased array methods to help prevent incidents from occurring on the pipeline. If you notice here in the picture I've shown, there's only one screen projection for finding results. Now we can do a lot with that singular screen projection, and I won't take away from ultrasound. If you notice here, it shows the singular transducer shooting one beam down. It's going at 45 degrees at this time. I tried to keep everything roughly about the same distance as I do on the phase array. I'm trying not to change the distance throughout these slides. Here is a representation of phased array. I want you guys to notice that phased array has multiple beams in here. We're running from 45 degrees all the way down to 70 degrees. Okay, here guys, I'm going to show you a difference in ultrasound and phased array. By overlapping them, you can see where the ultrasound only has the singular beam coming through, and then you have the beam spread, which we also use to help find our objectives. But if you notice in the phase array, we have multiple angles coming through, and you can see the size difference of coverage in this. Okay guys, here I'm going to show you a good example of phase array. I left all the numbers in here. You can see where this is actually a 1/4 inch piece of material. You can see the weld overlay, which mimics a ERW weld. You can see my distance here where it shows how far I am away from the center of the weld, and much more. You can see the little angles and everything else. So I want you guys to see why we want to use phase array. Generally, it's preferred because of the fact we get better coverage. We have the ability to record the data and show you everything throughout that weld at one time. And then it's just an overall better presentation showing the location, length, depth, height of any indication that we come across. Okay, we're going to go ahead and get into the heart of this whole discussion. This is a phase array scan. There's no issues. I'm going to go ahead and leave this material as flat. I'm going to have a 1/4 inch thick material throughout these few slides that I'm going to show you. But if you notice, try to keep your mind on where we're hitting. This is the 70-degree angle right here, the farthest one out where you see it bounce up. Now, I want you to keep your mind on that because that is going to change as we radius this material. Alright, now here is what I'm going to do. I've radiused this at 12.75, which is a common 12-inch piece. And I have not changed the thickness. The actual distance is the exact same. But if you notice, that area I told you to focus on is further out. It's closer to the back side of that weld overlay. And the thing is, I actually took 3 degrees out of there. I actually have it at 67 degrees here. I'm going to show you why in just a moment. Here, I left the 70-degree in, and if you notice, 70 and 69 are gone. They have kept going straight across, never touched the ID of the pipe, and headed back to the OD. And another thing about that is that as we get to steeper angles, we have what's called mode conversion. The sound will stop reflecting, and it will actually start traveling around the pipe, stealing energy from the beam, and that will cause another set of problems completely. And if you have a technician that doesn't understand this fully, they will have several problems with it. Now, because of what I've just shown you, I'm going to show you one of the main principles of all ultrasound, Snell's law. In Snell's law, we have an incident angle, which is the sound coming into the material. Now, that sound can be either reflected or it can go into the next material depending upon its velocity. When the sound is reflected, it is reflected actually the same angle as it came in, it will reflect out. But now, when it goes into the material, because of the velocity difference, you will see the angle will be changed and refracted just as if you were going light through water. Now, when we do this with a probe, I took all my angles out of this, but you can actually see here is our incident angle coming in from the probe, and then as soon as it hits the material, because there is a velocity difference, you'll see the angle will be changed. That is where we have our refracted angle. And then down here at the base of the material, the ID, the sound is then reflected. If you notice, those angles are exactly the same. These principles do not change in ultrasound. They stay the same at all given times. Now, what we've done here at NDE Solutions to try to fix these problems is we have our own custom blocks made, and if you can notice, this is an actual ERW weld, and we have the notches cut at 10% on the OD surface and 10% on the ID surface. This is actually a 250 wall piece as well. We try to get it as close as we can to the surface that we're going to be inspecting, because the change in thickness affects radius material quite a bit, as you've seen from earlier portions of this video. Now, by having these materials, we can actually try to see the problems when we have mode conversion and things of that nature. We see it in the setup before we even try to put it on your part. And we can correct that by taking angles out, and we can also try to adjust our setting of where we're going to shoot from. Now, you've seen in Snell's law all the rules that we follow, and we're trying to utilize everything we can to correct any problems before they occur in the field. We don't want to give you guys any bad information. And you know, when we train our technicians, we want them to be able to see when the sound is going to be robbed and start running around the pipe. We're going to try to teach them how to lay out a setup such that you get the best coverage that you can, and we will have them calibrate on a block so that the velocities are equivalent to give you accurate measurement. And that concludes our guide on proper ERW weld inspection. If you want any other information, you can reach me at NDE Solutions at 979-778-8783.